Here we go. Okay, we are on completing the square to get the formula of a circle. Now remember, a circle is x squared plus y squared equals r squared. Shh. Okay, now what would be the formula for the circle if our circle was displaced off of the 0, 0? In other words, this is a circle that is centered at 0, 0, right? Okay, it would be x minus h squared plus y minus k squared is r squared. Okay, you know those formulas, guys. You know everything about the circle, right? Because you know its center and you know its radius, all right? So here we have a circle. It is not in this form. How do I know it's a circle? Who can tell me how I know it's a circle? Wes?
It's in general form.
This is a general form, okay? But how do I know it's a circle and not an ellipse?
Yeah.
Because it's not divided by something.
Yes?
Because the x and y are squared.
X and y are squared, and you're getting closer. You're warm.
Isn't that the same thing on our ellipse, though?
Okay, it is.
Y are squared.
It is. X and y are squared. That's what I'm saying. What's different between the circle and the ellipse that I could see from the general form? Wes?
There's two different x's and y's.
Those aren't going to have anything to do with it. Yes?
Not perfect.
Huh?
Not perfect. I don't know.
Okay, this is a displaced circle, right? However, notice that the coefficient of the x and the y squared are both the same. Okay? If the coefficient of the x squared and y squared are the same, we have a circle instead of an ellipse. If we have an ellipse, those two coefficients are different. Okay? Because there's an elongation along one area. Well, be careful there, Cleveland. Thanks, Cleveland. Pick your feet up. All right, so what we're going to do is we have a circle, and we're going to complete the square. So we're going to complete two squares. We're going to complete two squares. All right, so I'm going to put everything that's x in this one, everything that's y on that one, and then I'm going to put over here negative 21. Okay? So now we've got what? This, when I complete the square, I'm going to put the negative 6x here. So I got that one and that one taken care of. I'm going to put the positive 8y here and then my negative 21 over there. So I need to complete the square here and here so that I get it into this form. Okay, so what will I do, Allie?
Divide the first one by 2.
Okay, so divide the negative 6 by 2 and I get a negative 3. Square it, right? I square it and plug it in here, but I can't just plug it in here, Wesley. What do I have to do now?
You have to put minus 9 over by the negative 21.
Why minus 9?
Because it's positive 9 there.
Yes, and I'm going to do the same thing to both sides of the equation. So shouldn't I put a positive 9 over there? If I put a positive 9 over here, and this is on the other side of the equation, shouldn't I put a positive 9 over there? Okay. So now, this is now a perfect square trinomial. What is the name of the perfect square trinomial, Susie?
The name is...
What is it going to be? When I complete the square. This is the completed square. What is this going to be when I put it in the little parentheses? Peter?
6 minus 3 is 6.
Very good. Okay. Now I'm going to do the same thing over here. Cleveland, what's going to be my first step?
Okay, I can see. It should be. Oh, I can see.
Come on, I'm growing older and older, Cleveland.
16.
What?
16.
Okay, but you're not going through the steps. You're skipping steps. How did you get that? You cut this one in half, right?
Oh, yeah.
You get a 4. You squared it.
Yeah, 16.
You got a 16. Now what do I do, Selena? If I added a 16 here, I should...
That was the stuff I knew. I don't know about that.
Zach?
Add 16 on it.
Thank you, Zach. Add a 16 over there. Okay, so now, Ian, what is this now? What is this factor now?
Y plus 4.
Y plus 4 quantity squared equals. Now I grab all and get all this stuff together, and what is 16 plus 9 minus 21? 4. Okay, so now I have the standard form. And the standard form tells me that this is a circle that is displaced to a center of what?
-3, no, 3.
3, -4. 3, -4, right? And it has a radius of what? 2. Remember? It's radius squared. So the radius is 2. So once you know that, don't you know just about everything you need to know? Okay? So that is the first example. All right, now look at the next example, which I have over here on the board. So we'll move this over a little bit. Okay? And get my eraser. And I almost did it. All right, so everybody, let's look at this one. And on this one, we have another circle in general form. General form has a 0 on one end. So what are we going to do? Start to what?
Separate x and circle.
Right, and again, I know it is a circle instead of an ellipse because these two have the same coefficients. So I'm going to have x squared. And how do I know it's a circle and not a hyperbola? What's a hyperbola?
Both are square.
Hyperbola has a minus in between. Okay, so a circle and an ellipse have pluses in between them. So you need to start recognizing these formulas. Yes,
What's
Peter?
hyperbola?
Hyperbola looks like this.
It's the.
That's a hyperbola. Okay, so here we go. We've got plus, and we're going to put our y squared pouch over here, and a plus 4x, and a minus 6y, and then I'm going to take my negative 6 and put it over here, right? Okay, so then what? Okay, divide by 2, get a 2. Square it, get a 4. Because I added a 4, I will what? Add a 4 on this side. I ran off my board. I cut this one in 2, -3. I square it, plus 9. I add a 9 over here on this side. This now is what, Robbie?
X plus 2 is 2.
X plus 2. Shh. Zach, slash. And this one right here, thank you, David. This one right here is what?
X minus 3. Squared.
Y
Y minus 3 squared equals, now let's grab all this and put it here. That's a 13 minus a 6 is a 7. It's not always going to be a perfect square. Okay, but can you tell me what the circle is? The circle is centered at what? 2, -3, right?
No.
2, 3. Thank you. 2, 3.
No,
-2.
No, technically them all.
I said
-2, 3. Thank you. Miss say how to.
Equal.
And then what?
square.
Square root of 7 squared.
Square root of 7. Thank you. Yes, Miss A was getting her signs all mixed up. All right, so that one was -2, 3, square root of 7. That was example number 2. Look at the next one because it has fractions. Okay? Let's look at the next one because it has fractions. And this one is x squared plus y squared minus 1/2 x plus 1/2 y minus 3/2 is 0. Okay, so this one, when I separate it into x's and y's,
That was the solution.
No.
No.
Yeah, the original problem was 2x squared plus 2y squared.
Oh, you're right.
minus 3.
I copied the wrong thing
We
down.
can just go backwards.
Okay, it says up here 2x squared. Yes, that's what I want to do. 2x squared, 2y squared minus x plus y minus 3 equals 0. Okay, so on this one, I'm going to do it a little different way from the way the book does it because I want you to see it 2 different ways. The book has it correctly. I'm going to do it a little differently. What if I just pulled down a 2x squared and a minus x, and I pulled down my 2y squared plus y. And then I put it equal to 3 on the other side. Now, what is my problem with just going on and completing the square like this?
You have to have a number 1 for the leading.
I need a 1 on this leading coefficient. Yes, I always need a 1 on this leading coefficient. Can I pull a 2 out?
Yes.
Can I pull a 2 out here? And then that's going to be a negative 1/2, isn't it? Okay, now I'm going to pull a 2 out over here. So that makes that a 1, like it's supposed to be, and this one a 1/2. All right? Now I don't have to change anything else. What they did at the start is they just divided the whole thing by 2. I'm just showing you a different way to work it. Okay? So now I'm still completing the square. Mark?
May I please go blow my nose?
Yes, you may.
No.
So this is going to be what? When I cut this in half. Okay, what is half of 1/2? Okay, 1/2 times 1/2 is 1/4. So negative 1/4, right?
And you play receiver.
Then when I square it, what do I get?
You just got a letter.
Peter slash, who else needs one? David slash, okay, Duncan, okay.
It wasn't Peter.
You guys,
Peter didn't even talk the whole time.
No.
okay,
It
all right.
wasn't Peter at
All right,
all.
it was Marcus, okay.
No.
All right.
Here's Wesley.
Okay, let's finish. Let's finish. Okay, so we square it. What did I just add there?
1/16.
Really? Look over here. Ian, what did I just add?
You add 116. 1/8.
No, somebody else just said that. Wake up.
1/8.
1/8. Why, Duncan?
Because it's half of 1/16. Well,
Yeah,
kind
it's
of.
2/16.
Yeah.
Really? It's 2/16, so that's 1/8. So over here, I'm going to add a 1/8. Okay, then I cut this one in half. And what do I get?
4.
1/4. And I square it. 1/16, which is really 2/16, which is 1/8. So I'm going to add 1/8 to the other side. Do you see how that number outside changes things a little bit? So now what are my factors here? Marcus?
X minus 1/4 squared, y minus plus 1/4 squared.
Okay, and then a two in between, and then when I add 3 plus an 8 plus an 8, I get a what?
2 and a 4.
Okay, I get 3 and 2/4.
1/4.
1/4.
26.
Okay, is that good? So now I've got it in its standard form. I mean, yeah, that's its standard form. So this is telling me what? I would write that differently. How would I write that? 13 fourths, and then when I take the radius, it's the square root of that. But the 4 on the bottom would make it r is square root of 13 over 2, wouldn't it? Okay, so the radius should be,
You gotta multiply it by 2.
why did I get that?
Because you gotta get that 2 out. Don't you?
Oh, you're right. That's still a 2, and that's still a 2. And so basically right here, if I divided everything by 2, that would be 13 fourths divided by 2, which would be
2 on the bottom.
8 on the bottom, right? And then when I took the square root of that, it would be the square root of 13 over 2 square root of 2. But then when I multiplied it by the square root of 2, I get square root of 26 over what? 4? Okay, and that is the correct radius. So that's my radius. And these are negative 1/4 and positive 1/4 and negative 1/4. So positive 1/4 and negative 1/4 is your center. Okay, everybody.